Starting to see some attendees showing up.
JC, I can see you. It looks like participants have.
This session. I trust you've enjoyed the week so far, but the best is yet to come. Let me share with you a small presentation here, just so you don't have to look at me. You can look at something hopefully a little bit more interesting. And let's get going. Let me make sure I stay on time here. So as you've heard, AFWERX is looking at defining the next prime in a technical sector that stands to transform both the commercial and the military areas. And I cannot think of a technology that will have more profound implication than autonomy and artificial intelligence. So Ben Tran, whom you heard yesterday, asked me to set the stage for the discussion that we're about to have on how to best design autonomous prime. So I like to start any conversation about autonomy with a definition and a reminder. Simply stated, autonomy is a command and control paradigm in which one cedes a portion of their authority to a subordinate, in our case, a machine. Or from the subordinate perspective, autonomy is the freedom to select a course of action to achieve my superior's objectives, not my own objectives, but my superior's. And this distinction is important and leads me to the reminder that autonomy is not independence. We all know the difference. I'm quite sure you've never been invited to an Autonomy Day barbecue on the 4th of July. And I certainly have never seen an RFP for an independent missile, tank, or plane. System is autonomous only when it remains under our control and does our bidding. More on that a little later. But for now, let's move on to see what we try to achieve with autonomy. And our goal with autonomy is to increase the speed and the quality of decisions in everything we do, in combat, of course, but also in other activities occurring every day, from the back office to the launch pad. In all cases, our aim is to augment human decisions, not replace them. Sometimes we need to augment them because of reduced connectivity, as for example, in the case of unmanned systems, and sometimes it's to overcome the constantly growing complexity of our activities. In all cases, though, the system is there to translate the human high-level command into actionable tasks. The second objective for autonomy is to accelerate the pace. Again, not just in combat, but for everything we do. The world is not slowing down, and nor shall we. All right, with the definition and objective set, let's discuss what we put under the label of autonomy at AFRL. So we divide autonomy into two buckets that share many common attributes, but don't fully overlap. We call the first bucket autonomy at rest. You can think of this as decision aids that collect the data, manipulates it, fuses it, presents it, and makes some recommendation on the best course of action to the operator. This is very much in line with what Professor Sandholm just mentioned in the plenary session. The second element is the autonomy in motion. In that case, the system can take the next step to implementing the course of action within its authorized bounds and close the loop. But in both cases, we need a system that is more robust and that doesn't break easily when encountering new situations. And for that, we are leveraging artificial intelligence. So AI allows us to consider much broader decision space, take into account many more signals, resulting in a more flexible autonomous system. So without intelligence, autonomy is limited to the simplest applications and the only element that we need, but this is not the only element that we need to work on advanced autonomy. So let's talk about the next elements. So I use a simple framework that is more or less application agnostic and consists of the following four elements, so the three pillars and a foundation. So the three pillars supporting our goal of better and faster and more robust decisions are first algorithms. So in this pillar, you find essentially all the algorithms needed to observe the environment, develop an operating picture, analyze the options going forward, and in the case of autonomy in motion, implement the actions and monitor the system performance. The center pillar is the human system interface. At the center of any autonomous system lies an operator. They are the ones who set the objectives, the constraints, and preferences. They oversee the operation and make sure the system is indeed implementing their intent. Given the state of the art of algorithms, the operator, in many cases, need to be able to step in at different level of interactions. So these are high-level requirements for the human system interface. The last pillar is trust. Without trust, there is no autonomy. Trust is a complicated subject that encompasses elements of psychology, transparency, formal verifications, testing, security, and even ethics. But the outcome couldn't be simpler. It's the difference between the system being used or not. So without trust, no autonomy, and we need to work on that. Finally, these pillars rest on a foundation that link them to the entire ecosystem. This ecosystem is vast and includes academia, small businesses, labs, and large businesses. The importance of that is that autonomy, unlike other critical technologies, can be meaningfully contributed to by anyone. And the idea of the open environment that some people call infrastructure is to really facilitate this contribution. And within this open environment, you probably need to start with an open architecture, then have a DevSecOps environment supported by robust data, variable fidelity modeling and simulation, etc., as well as the test equipment that we need to run that. This is where we anticipate autonomous prime can make the biggest contribution. But the point of the workshop is to open a dialogue with you and discuss how can AFWERX accelerate the pace of development and deployment of autonomous systems. What do you think is the most impactful action AFWERX can take that will ensure the U.S. remains the leader in autonomy both for commercial and military application. What barriers can we remove and how? Sometimes it's not about removing barriers, but adding oil to the machine. How can we create an environment where you can turn your ideas into a product more rapidly? For the last couple minutes I have, I wanted to turn over to a colleague and friend of mine who is a surprise guest today, and he's the Dr. Al Lois. He's the chief scientist for the Air Mobility Command. And Al, in the next 2 minutes, can you kind of paint what you expect out of autonomy?
Great, thank you, JC. It's been a pleasure to work with you over the years and a pleasure to speak to the audience here. That you see the video. Yes, also a huge pleasure to work with here at Air Mobility Command. When you think about Air Mobility Command, I want you to think about the world's largest airline before COVID, and we're about the same size. Think about over 100,000 personnel, about 1,100 aircraft, tankers and heavy transport aircraft, all about the same size, and some actually derivatives of commercial airlines. We need to be at the leading edge of autonomy in order to project that logistics around the world, which is our job. Think of it right now, we have a takeoff with an Air Mobility Command aircraft about every 6 seconds. And I break that down into about 3 different types of autonomy. Pretty much what you talked about before, but I kind of segment one of your areas into 2. First is just like many other airlines. We need instantaneous replanning. If you remember before COVID, when you were going down to Florida and your flight maybe couldn't work, you had to jump onto another airplane as quick as you could. That type of instantaneous replanning is critical for Air Mobility Command too. Improve forecasting for worldwide demands, improve situational awareness, and improve warnings like when a volcano goes off. All those are standard airline type and also air mobility type planning options that need enhanced autonomy. Second, we are an office just like any other office. If you think about over 100,000 personnel, that requires basic office functions from personnel management to finance management and the like. And that requires things like robotic process automation, low-code automation at the point of the user, global spares forecasting and fuel posture. If we have airplanes that go to deliver disaster relief around the world, we need to be able to figure out what spares need to go forward with that airplane so we can get the airplane back out at that disaster relief location. And we need overall autonomy to transform data into information. The third area is more or less specific to global mobility, but it does relate also to commercial in some ways. Autonomous cargo loading. If you think about going out to the airport, you still see people loading bags on airplanes. Much larger scale, and autonomous cargo loading, autonomous ground operation, autonomous flight operations. You think over 1,100 airplanes, and anything we can do to get autonomy in flight to allow pilots and co-pilots and other airborne personnel to be more think and less having to less do the dull and routine type actions. That would be great. Also looking for autonomous defense, because there are many new threats, even like the little small UAVs, that we need to improve our autonomous based defense for. The large area of in air.
Thank you very much for this very brief overview, and I yield the floor to Brigadier General Britton now to talk about another potential prime. Thanks again, Al.
Thank you.